The very first one is which will be done by Sandeep Dungana sir. So which is who is a STEM scholar at Department of STEM Education, and so the presentation actually emphasizes on the actually the experiences learning in statistics in mathematics, and the second presentation will be done by our Dr. Roshan Rajbangshi, so which will be focused on actually the arts and mathematics in science education. So Sandeep sir, I think you are ready with your presentation.
Yes, sir.
Okay, so I request you to share your presentation slides.
Okay. I hope this is visible.
Yeah, it's visible. So please begin.
Thank you, Nedu sir. Okay, namaste to all. Today I am here in presenting my experience and something about experiential learning in teaching statistics in school level. And I am Sandeep Dungana, MPhil scholar, Kathmandu University School of Education. Let me begin my presentation with different ways of learning. What could be the different ways of learning that we start with? The very first one is technical learning, and the second one is practical learning, and the third one is emancipatory learning. What is technical learning? And technical learning, it talks about objective reality, and it talks about environmental control and rule following activities, just like in conventional type of teaching learning strategy or conventional classroom. And let's key what is learning, what life focus garcha bhane. The second one is practical learning, which focuses more on the process and construction of knowledge by the co-construction अथवा constructing knowledge together. Subjectivity लाई बढी focus गर्छ भने it depends on, or it is based on, it's grounded on interaction to generate the understanding and sense making. त्यसको कुरा चाहिँ practical learning ले गर्दाखेरि emancipatory is more focused on critical learning and a critical perspective. It promotes social justice and equitable being, and let's say self reflection अथवा self critical realization, self critical reflection को कुरा पनि यसले जोडिराख्छ र यो तरिकाले चाहिँ यो तीन तरिकाले चाहिँ हामीले लर्न गर्न सक्छौं भन्ने कुरा आउँछ. Likewise, different ways of teaching in the pedagogy. What is the pedagogical perspective? Pedagogical perspective बाट हेर्दाखेरि the first one is informing pedagogy. What के छ त जे छ त्यही कुरा यस्तो छ है, इन्फर्म गर्ने भएको कुरालाई जस्ताको जस्तै दिने. And second one is reforming pedagogy. त्यो प्रोसेसलाई यो कुरा छ कसरी भइरहेछ, हाउ हैन, त्यसको प्रोसेसको कुरा गर्छ यसले हैन. And third one is transforming pedagogy. Why, किन चाहियो त्यो हैन, कसरी भयो, किन चाहियो, त्यो नभइदिए अब के हुन्छ, त्यसको अल्टरनेटिभ के हुन्छ, त्यो कसका लागि फोकस छ, किन फोकस छ, कसका लागि चाहिन्छ, किन चाहिन्छ, यस्ता कुरा चाहिँ ट्रान्सफर्मिङ पेडागोजीले गर्ने गर्छ. And here with this slide, and यसले चाहिँ school education in the present context, and the scenario of present context can be seen in this slide. The very first one is the first picture talk about authoritarian teacher, and यसले चाहिँ एउटा control environment, and एकजना टीचर एकजना लर्नर को बीचमा चाहिँ एउटा control environment है, जुन हामीले conventional classroom मा देख्न सक्छौं, एउटा strict environment जहाँ teacher is everything, टीचर सेन्टर पेडागोजी हैन, त्यो खालको इन्भाइरोमेन्ट हैन, जुन इन्भाइरोमेन्टमा हामी ग्रो गर्यौं त हामीले पढ्यौं अथवा हामीले सायद पढायौं अथवा त्यो किसिमको इन्भाइरोमेन्टलाई फर्स्टले फोकस गरिरहेछ भने. सेकेन्ड वान इज वेटर पेडागोजी हैन, जसमा चाहिँ एउटा टिचरले एउटा रेडिमेड नलेजलाई लगेर स्टुडेन्टसम्म पुर्याउने गर्छ. जस्तो if you talk about mathematics learning, then what we are focusing, like we are giving all the process and everything to the students. And as a teacher, I can also reflect on my earlier practices of teaching career. And I can reflect on my learning strategy. That represent the waiter pedagogy. And teacher le complete framework problem solve complete framework teacher le the framework la student le copy garne, त्यो framework ma just student used to insert the numerical values only. हैन न्युमेरिकल भ्यालु चाहिँ रिप्लेस मात्र गर्ने सबै कुरा सेम हुन्थ्यो जस्ट नम्बर मात्र फरक गर्ने क्याल्कुलेट गर्ने एन्ड दोस टाइप अफ पेडागोजी वाज देयर एन्ड इभन इफ यु टक अबाउट अदर सब्जेक्ट्स अल्सो इङ्ग्लिस नेपालीमा पनि कस्तो देखिन्छ भन्दा टिचरले इभन एसे पनि टिचरले लेखेर स्टुडेन्टलाई घोकाउने टाइपको न द्याट इज वेटर पेडागोजी त्यसमा स्टुडेन्टको क्रिएटिभिटी देखेन तर स्टुडेन्टको नलेज देखेन टिचरको नलेजलाई नै जे छ जस्ताको जस्तै स्टुडेन्टले त्यसलाई मात्रै पर्सिभ गर्यो ओके एन्ड स्टुडेन्टले चाहिँ त्योभन्दा बाहिर सोचेन एन्ड दिस थर्ड पिक्चर इज हेल्पलेस स्टुडेन्ट टिचर सेन्टर पेडागोजी अथवा टिचर सेन्टर क्लासरुममा के भयो त भन्दा स्टुडेन्ट्स डु नट ह्याभ इनफ रुम टु एक्सप्रेस देयर फिलिङ्स एक्सप्रेस देयर थट्स एक्सप्रेस देयर ओपिनियन एक्सप्रेस देयर क्रिएटिभिटी एन्ड स्टुडेन्टको मुख चाहिँ बन्द गराइयो दे आर नट एबल टु स्पिक इन द क्लास एन्ड द next one is take down notes भनेको चाहिँ it's like this same like waiter pedagogy no टिचरले नोट बनाउने घरमा टिचरले धेरै अध्ययन गरेर धेरै किसिम एउटा फाइनल फर्म अफ नलेज भनेर जसरी एउटा नोट जसरी लिएर जाने स्टुडेन्टलाई त्यही दिने स्टुडेन्टले त्यही पढ्ने त्यही घोक्ने त्यही याद गर्ने र एक्जाममा गएर त्यही कुरा लेख्ने जस्ट यो के भयो त भन्दा त्यही एउटै कुरालाई चाहिँ फलो गर्ने अथवा त्यही कुरालाई रिकन्स्ट्रक्ट रिप्रोड्युस गर्ने कुरा मात्रै रिप्रोड्युस गर्ने काम मात्र भयो भने एन्ड द नेक्स्ट पिक्चर इज हियर यसमा पनि टिचर सेन्टर क्लासरुममा देखिएको छ टिचरले विभिन्न नलेजका ठुला ठुला बुकहरूलाई ग्राइन्ड गरेर त्यसबाट नलेज निकालेर त्यो नलेजलाई चाहिँ स्टुडेन्टको हेडसम्म पुर्याउने काम गरिरहनु भएको छ यसमा चाहिँ स्टुडेन्ट्स दे आर प्यासिभ हैन टिचर एक्टिभली किताबलाई अथवा किताबमा धेरैवटा किताब भएको नलेजलाई ग्राइन्ड गरेर स्टुडेन्टको लागि बेस्ट नलेज निकाल्ने कोसिसमा हुन्छ भने स्टुडेन्ट्स दे आर जस्ट पर्सिभिङ द्याट नलेज विदाउट एनी एक्सन हैन यसमा केही एक्सन देखिराखेको छैन दे आर जस्ट पर्सिभिङ द नलेज इन प्यासिभ फर्म हैन अनि सबैले एउटै नलेज एउटै कुरा चाहिँ त्यहाँबाट लिइरहेका छन् जुन टिचरबाट आइरहेको छ दिस इज द करेन्ट सिनारियो अफ आवर स्कुल प्र्याक्टिसेस हैन मोरओभर हाम्रो मेजोरिटी अफ द स्कुलहरूले के गरिरहेछ भन्दा अथवा हामी नै के गरिरहेछौँ भन्दाखेरि वी आर फलोइङ दिस सर्ट अफ पेडागोजी इन आवर स्कुल एजुकेसन वाट डु वी वान्ट हामी के चाहन्छौँ त हैन हामी रियली यो प्यासिभ लिसनर जसमा चाहिँ टिचर एउटा लेक्चर मात्रबाट टिचरले जे दिन्छ स्टुडेन्ट त्यतै लिने एउटा प्यासिभ लिसनरवाला चाहन्छौँ या त एक्टिभ इन्क्वायरर अथवा एक्सप्लोरर टिचर स्टुडेन्ट सँगै बसेर चाहिँ नलेजलाई को कन्स्ट्रक्सन गर्नको लागि लाग्ने अथवा दुवैजना मिलेर नलेज एक्सट्र्याक्ट गर्ने अथवा स्टुडेन्टले आफै इन्भल्भ गरेर त्यो नलेजलाई निकाल्न सक्ने त्यो किसिमको हामी चाहन्छौँ या त टिचरले सबै रेडिमेड कुरा स्टुडेन्टको हेडमा लाइक जस्ट लाइक थिङ्किङ लाइक स्टुडेन्ट्स आर इम्टी भेहिकल हैन उनीहरूको इम्टी माइन्डमा लगेर टिचरले आफूले जानेको कुरा अथवा आफूले एक्सपिरियन्स गरेको कुरा सबै स्टुडेन्टको हेडमा लगेर त्यही अनुसारले राखिदिने कुरालाई हामी do we want that or we want this another type of pedagogy which is in the second picture के चाहन्छौँ त हामी let's question with ourselves what we are practicing हैन तिनै कुरालाई मैले ल्याएर चाहिँ थोरै ल्याएको छु यसमा मैले तीनवटा केसलाई रिप्रेजेन्ट गर्न खोजिरहेको छु र तीनवटा केसमध्ये हामीले आफैलाई हेरौँ हामी कुन केसमा पर्छौँ भनेर हैन the very first one the first case one is I have a packet of knowledge in my hand हैन I have a package of knowledge in my hand मसँग मेरो हातमा नलेज छ मेरो हातमा एउटा कन्क्रिट करिकुलम छ टेक्स्ट बुक छ एउटा स्ट्यान्डर्ड फर्म अफ नलेज छ स्ट्यान्डर्ड करिकुलम छ हैन त्यसलाई मैले के गर्छु त आई शुड ट्रान्समिट इट एज इट इज टु माई स्टुडेन्ट त्यहाँ जे छ त्यही कुरालाई मैले एज इट इज स्टुडेन्टलाई दिने हो अथवा दिइरहेको छु अथवा के छ हैन दिस इज द केस वान हामीले आफूलाई रिफ्लेक्ट गर्दै जाउँ हामी कुन केसमा पर्दो रहेछौँ द सेकेन्ड वान इज केस टू आई हेभ अ प्याकेज अफ नलेज इन माई ह्यान्ड इट इज सेम लाइक एभव हामीसँग त्यही कुरा छ हामीसँग करिकुलम छ हामीसँग टेक्स्ट बुक छ हामीसँग त्यही माथि जे त्यही कुरा छ आई शुड रिफर्म इट एन्ड इम्प्लिमेन्ट बेस्ड अन द निड्स एबिलिटिज एन्ड इन्ट्रेस्ट अफ स्टुडेन्ट्स एन्ड कम्युनिटी हैन मैले चाहिँ एउटा विद्यार्थी र कम्युनिटीको इन्ट्रेस्ट अनुसार एबिलिटी अनुसार उसको निड अनुसार यसलाई रिफर्म गरेर यसलाई मोडिफाई गरेर चाहिँ त्यहाँनिर इम्प्लिमेन्ट गर्नुपर्छ र त्यहाँनिर टिच गर्नु बढाउनुपर्छ भन्ने कुरा चाहिँ सेकेन्ड केसले गर्छ हामीले गरिरहेछौँ छैनौँ अथवा कहाँ छौँ हामी यो कुरालाई थोरै रिफ्लेक्ट गरौँ लाइकवाइज केस 3 इज देयर केस 3 ले थोरै केस 2 कै कुरा पनि केस 2 कै कुरालाई जोडेर थप कुरा जोड्ने छ आई हेभ अ प्याकेज अफ नलेज इन माई ह्यान्ड द्याट इज सेम त्यही कुरा छ आई शुड रिफर्म इट इम्प्लिमेन्ट बेस्ड अन द निड एबिलिटी एन्ड इन्ट्रेस्ट अफ स्टुडेन्ट कम्युनिटी यो माथिको कुरा केस 2 को कुरा सबै आइरहेछ हुबहु आइरहेछ बट नट ओन्ली द्याट त्यति मात्र इनफ छैन है द्याट इज नट इनफ आई शुड अल्सो क्रिएट क्रिटिकल स्पेस फर स्टुडेन्ट्स हैन त्यसमा क्रिटिकल कुरा गयो अथवा आउट अफ द बक्स यहाँ जे छ त्योभन्दा आउट अफ द बक्स स्टुडेन्टलाई सोच्ने गरी हामीले इनफ स्पेस क्रिएट गरिरहेको छौँ कि छैनौँ? डु दे गेटिङ द्याट इनफ स्पेस, द्याट स्पेस विच वेयर दे क्यान थिङ्क क्रिटिकल्ली अन द्याट फेनोमेनन भन्ने कुरा पनि हामीले सोच्न सक्छौँ होइन। अब हामीले आफूलाई रिफ्लेक्ट गर्न सक्छौँ, हामी केस 1, केस 2 र केस 3 मध्ये हामीले के कुरा गरिरहेको छौँ, हामी कुन प्र्याक्टिसमा छौँ, वाट वी आर प्र्याक्टिसिङ। यसमा लामो सेन्टेन्स छ एउटा जुन स्पिड 1986 लेखेको कुरा, यसलाई मैले पढ्न चाहिनँ। यसले केलाई फोकस गर्छ अथवा यो पेपरले केलाई फोकस गरेको छ भन्दाखेरि यसले भन्छ हामीले चाहिँ पढाउँदाखेरि होइन लाइक गुड एप्रिसिएसन चाहिँ के हुन्छ त भन्दाखेरि स्ट्याटिस्टिक्स पढाइरहँदाखेरि अथवा हामीले म्याथमेटिक्स अथवा कुनै कन्टेन्ट पढाइरहँदाखेरि के छ त भन्दाखेरि हामीले त्यसको मेथड जान्नुभन्दा त्यसको थिङ्किङ होइन, अथवा यहाँनिर स्ट्याटिस्टिकल कुनै पनि लर्नरलाई स्ट्याटिस्टिक्स पढाइरहँदाखेरि स्ट्याटिस्टिकल मेथड, उसले कुनै मिन निकाल्न जान्ला, मिडियन निकाल्न जान्ला अथवा समथिङ एल्स होइन, त्यो मेथड जान्नुभन्दा पनि उसको स्ट्याटिस्टिकल थिङ्किङ चाहिँ डेभलप गर्नु चाहिँ इम्पोर्टेन्ट हो, अथवा द्याट इज अ गुड एप्रिसिएसन, द्याट सुड बी द रियल नलेज भन्ने कुरा यो पेपरले पनि गरेको छ। जस्तो कुनै पनि स्टुडेन्टले मिन निकालिरहँदाखेरि उसले प्रोसिड्युरली मिन निकाल्न सक्दा त्यो दिएको आउटपुटले के रियल लाइफमा के मिनिङ दिन्छ, वाट डज इट मिन भन्ने कुरा बुझ्नु अथवा स्ट्याटिस्टिकल थिङ्किङ डेभलप गर्नु। कुनै रियल लाइफमा गइरहँदाखेरि यो डेटा हेर्दाखेरि यसबाट यो निकाल्दाखेरि यसरी निकालिन्छ भनेर रियल लाइफ प्र्याक्टिसमा पनि ऊ इन्गेज हुन सक्नु, द्याट माइट बी द स्ट्याटिस्टिकल थिङ्किङ विच इज बेटर देन जस्ट टु नो अर जस्ट टु लर्न स्ट्याटिस्टिकल मेथड भन्ने कुरा यो यहाँनिर र यो पेपरले गरेको छ। अब यहाँबाट गर्दै जाँदाखेरि म एक्सपिरियन्सियल लर्निङमा छिर्ने कोसिस गरिरहेको छु। एक्सपिरियन्सियल लर्निङमा जाँदै गर्दा चाहिँ एक्सपिरियन्सियल लर्निङ भनेको एक्सपिरियन्सबाट लर्न गर्ने, आफै कुनै पनि फेनोमेननमा, कुनै पनि प्र्याक्टिसमा, कुनै पनि रियल लाइफ सिनारीमा आफै इन्भल्भ भएर त्यहाँबाट लर्न गर्ने होइन त। त्यसले गर्दाखेरि लर्निङ फ्रम एक्सपिरियन्स अर लर्निङ बाई डुइङ होइन। कुनै पनि लर्नरलाई चाहिँ स्ट्याटिस्टिक्सलाई हामीले जुन स्ट्याटिस्टिक्सको कुरा गरिरहेको छौँ, यो स्ट्याटिस्टिक्समा मात्र नभएको जहाँ पनि भन्ने भए पनि अहिले स्ट्याटिस्टिक्सलाई बढी फोकस भएको स्ट्याटिस्टिक्सको कुरा गरिरहँदाखेरि स्ट्याटिस्टिक्समा एक्सपिरियन्सियल लर्निङलाई इन्भल्भ गरिरहँदाखेरि चाहिँ स्टुडेन्टलाई स्ट्याटिस्टिकल डेटा कलेक्सन, त्यसलाई डेटा रिफाइनिङदेखि लिएर हरेक कुरामा इन्भल्भ गरायो भने दे क्यान लर्न from that perspective in a better way, and that could be a experiential learning, and it involves student making connection between the question के छ क्वेसन, हामीले के क्वेसन लिएर फिल्डमा जाँदैछौँ, डेटा डिसाइडिङ एन्ड द इम्प्लिकेसन एनालाइटिकल स्टडिज एन्ड कम्युनिकेसन फाइन्डिङ होइन। डेटा सर्वेमा जाला, डेटा लिएर आउला, डेटालाई रिफाइन गर्ला, एभोल्युसन गर्ला, विभिन्न फर्ममा त्यसलाई प्रेजेन्ट गर्ला होइन। यो बिचको कनेक्सन चाहिँ उसले आफै इन्भल्भ गरेर गर्न सक्छ इन एक्सपिरियन्सियल लर्निङ। अनि यो भइरहँदा के भयो त भन्दा मिनिङफुल टु द स्टुडेन्ट विथ गाइडेड रिफ्लेक्सन एन्ड एनालाइसिस। It will promote the meaning making process in the students, and student can process real life scenarios, experiment with a new behavior and receive feedback, and they can immerse themselves in a real life scenario. They can collect the numerical values, they can collect the data from the experiments, from their real life scenario, the real life settings where they are familiar with, and they can help, it can help, this type of learning can help students relate their theory to the practice and realize or analyze the real life situation, where they can learn the theory part. Theory, हामीले theory त पढाइरहेको छौँ नि, theory कति पढाउँछौँ हामी, mean पढाउँछौँ, median पढाउँछौँ, standard deviation पढाउँछौँ। एउटा स्टुडेन्टले mean निकाल्दा standard deviation निकाल्छ, तर mean र standard deviation को रिलेसन के त, त्यसले भन्न खोजेको कुरा के भन्ने कुरा धेरै विद्यार्थीले अहिले पनि बुझिरहेको हुँदैन र हामी एज अ टिचर पनि त्यसलाई बुझाउन जरुरी ठानिरहेको हुँदैनौँ, बिकज द्याट वन्ट बी आस्किङ द एक्जामिनेसन हैन। हामी एक्जाम फोकस छौँ, त्यसले गर्दाखेरि this type of thing we are lacking with those sort of things. यसमा मैले प्रोसिड्युरल अन्डरस्ट्यान्डिङ भनेर राखेको छु। यसमा मैले सिम्पल हाम्रो बेसिक टाइप अफ डेटा राखेको छु। यसमा इन्डिभिजुअल डेटा, डिस्क्रिट डेटा र कन्टिन्युअस डेटा मैले किन ल्याएँ त यहाँनिर भन्ने कुरामा, जस्तो फर्स्ट वान इन्डिभिजुअल डेटा छ 2 5 7 10 गर्दै राखेको छु मैले। यो न्युमेरिकल भ्यालुले कुनै पनि कुरा रिप्रेजेन्ट गरेको छैन यहाँनिर, सिम्पली दे आर द नम्बर्स। अनि यो राखिरहँदाखेरि चाहिँ तल्लो डिस्क्रिट डेटा भनेर मैले डिस्क्रिट टेबल बनाएको छु। अनि एक्स छ, एफ छ, विद्यार्थीले धेरैले त एफ को मिनिङ बुझिरहेको हुँदैन, एफ एउटा फ्रिक्वेन्सी हुन्छ भने एफ को फुल फर्म फ्रिक्वेन्सी भनेर बुझिरहेको हुन्छ। हैन त्यहाँ 10 छ त्यहाँ 2 छ नो इन माई एक्सपिरियन्स मैले धेरैजनासँग विद्यार्थीहरूसँग संगत गरेर पढाइरहँदाखेरि चाहिँ मैले के पाएको छु भन्दा यो विद्यार्थीले 10 र 2 यो 20 र 5 बिचको कनेक्सन नै बुझिरहेको हुँदैन यो 2 भनेको चाहिँ 10 दुईचोटि रिपिट हो भन्ने कुरा उसले बुझिरहेको हुँदैन 10 भनेको अथवा 20 भनेको 30 भनेको x को भ्यालुहरू f भनेको यो f को 2537 भनेको f को भ्यालुहरू मिन निकाल्नु छ भने हामीले x र f लाई मल्टिप्लाई गर्ने 10 2 जा 20 गर्ने सो fx को भ्यालु जोड्ने समेसन fx निकाल्ने n निकाल्ने समेसन fx मा n गर्ने मिन निकाल्ने नो दिस जस्ट नो दिस मच हैन यो 10 भनेको 2 यो तलतिरको 2 ले चाहिँ 10 दुईचोटि रिपिट भएको छ है भन्ने कुरा रिप्रेजेन्ट गर्छ 10 into 2 20 निकाल्नु भनेको 10 10 जोडेर 20 हो यो कुरा उसले यसरी बुझिरहेको हुँदैन तर कन्टिन्युअस डेटाको केसमा पनि त्यही हुन्छ हैन तर अब एक्सपिरियन्शियल लर्निङ गरिरहँदाखेरि के हुन्छ त भन्दाखेरि बच्चाले आफै डेटा कलेक्सन गर्छ उ फिल्डमा जान्छ फिल्डमा गएर लिँदाको डेटा त त्यो डिस्क्रिट डेटा कन्टिन्युअस डेटा सिधै आउँदैन उसले के गर्छ र फर्ममा डेटा कलेक्सन गर्छ उसका यो 10 10 दुईचोटि रिपिट हुन सक्छन् त्यहाँनेर उसले 20 25 टाइम्स रिपिट भएको उसले देख्न सक्छ त्यसबाट त्यो डेटालाई उसले टेबुलेसन गर्छ उसले डिस्क्रिट टेबल बनाउला उसले कन्टिन्युअस टेबल बनाउला अथवा उसले अर्को फर्ममा रिप्रेजेन्ट गर्न सक्ला उसले त्यो र डेटाबाट विभिन्न फर्ममा कन्स्ट्रक्ट डिकन्स्ट्रक्ट गरिरहँदाखेरि यो फेनोमेननसँग यो प्र्याक्टिससँग यो कसरी आयो भन्ने मिनिङसँग यसको मिनिङसँग ऊ फ्यामिलियर हुँदै जान्छ एन्ड ही अर सी माइट गेट अ बेटर अन्डरस्ट्यान्डिङ फ्रम दिस एक्सपिरियन्स अनि यो मात्रै यो गरिरहँदाखेरि चाहिँ आई थिङ्क अ लर्नर क्यान लर्न फ्रम द कन्टेक्स्ट फ्रम द रियल लाइफ सिनारियो एन्ड क्यान एप्लाई इन द अपकमिङ डेज अल्सो होइन उसलाई कुनै अर्को ठाउँमा गएर सर्वे लिनु पर्यो अथवा के गर्नु पर्यो भने पनि उसले यो कन्सेप्टलाई त्यहाँ लगेर एप्लाई गर्न सक्छ त्यहाँनिर युज गर्न सक्छ उसले यहाँनिर डेटा कलेक्सनको कुरा मात्रै बुझेन डेटा कलेक्सनबाट कस्तो डेटा आउनु रहेछ भनेको हाम्रो टेक्स्ट बुकमा दिइरहेको डेटा चाहिँ कहाँबाट ल्याएको रहेछ कसरी आउँदो रहेछ यसले चाहिँ के रिप्रेजेन्ट गर्दो रहेछ भन्ने कुरा हरेक किसिमको मिनिङ चाहिँ उसले बुझ्ने भयो द नेक्स्ट वान इज वाट दे नो एन्ड वाट नट इन माई पर्सपेक्टिभ एउटा नर्मल लर्नरले एउटा अर्डिनरी लर्नरले के जानिरहेको हुन्छ के जानिरहेको हुन्छ त्यसको बेसमा थोरै डिफ्रेन्सिएट गरिहेरौँ what they know and what they do not they can calculate the mean median and so on हैन यस्ता स्ट्याटिस्टिकल कुराहरू उनीहरूले सजिलैसँग क्याल्कुलेट गर्छन् हैन जस्तो हामीले स्ट्याटिस्टिक्स लिइरहँदाखेरि स्ट्याटिस्टिक्स माइट बी अ इजी टपिक फर मेनी अफ द लर्नर्स तर यो इजी टपिक भइरहँदा के मानेमा इजी हो त के कारणले इजी हो त अथवा के कुराको लागि इजी हो त भन्ने कुरा रहन सक्छ एन्ड they are feeling easy just to calculate just to find the output हैन दिएको एउटा होरिजोन्टल टेबलमा एउटा डेटा होला त्यसलाई भर्टिकली रिप्रेजेन्ट गर्ने x होला f होला हैन त्यहाँ fx निकाल्नु पर्ने होला अथवा cf निकाल्नु पर्ने होला m निकाल्नु पर्ने होला fm निकाल्नु पर्ने समथिङ एल्स उसले प्रोसिड्युरल बुझेको छ उसले टेबल याद गरेको छ अनि यो लास्टको कुरालाई जोड्ने अनि त्यसपछि त्यसलाई n ले डिभाइड गर्ने अथवा समथिङ एल्स त्यो हिसाबले उसले एउटा फर्मेट उसले याद गरेको छ र त्यो फर्मेट उनीहरूले हरेकचोटि के गर्छ न्युमेरिकल भ्यालु रिप्लेस गर्छ र नयाँ नयाँ एन्सर मात्र निकाल्छ दे क्यानट मेक इट्स इन्टरप्रिटेसन हैन त्यसले के भनिरहेको छ त त्यसको मिनिङ के हो भनेको मिनिङ मेकिङमा वी आर ल्याकिङ इन द मिनिङ मेकिङ प्रोसेस भन्ने कुरा यो फर्स्टले जोड्न खोजिरहेछ भने दे क्यान युज द गिभन फर्मुला उसले टेक्स्ट बुकमा दिएको फर्मुलालाई कुनै न्युमेरिकल भ्यालुमा अथवा कुनै न्युमेरिकल क्वेसनमा एउटा न्युमेरिकल प्रब्लममा उसले एप्लाई गर्न सक्छ बट डोन्ट नो हाउ द्याट फर्मुला हेज डिराइभ्ड त्यो फर्मुला सामान्य रूपमा हामीले कुरा गर्ने हो भने पनि मैले धेरैचोटि देखिरहेको छु बच्चाहरूले इन्डिभिजुअल सिरिजको अथवा इन्डिभिजुअल डेटाको मिन निकालिरहँदा पनि कति ठाउँमा समेसन एफएम बाई एन लेखिरहेको हुन्छ अथवा समेसन एफएक्स बाई एन लेखिरहेको हुन्छ त्यहाँनिर एफ छैन एफसँग मैले मल्टिप्लाई गरेको छैन मैले एफ लेखिरहनु पर्दैन समेसन एक्स बाई एन गर्दा हुन्छ अथवा एम मैले मिड भ्यालु निकालिरहेको छैन यो अर्कै खालको डेटा हो भने त्यो पनि उनीहरूमा ल्याकिङ छ दिस जस्ट पुट द भ्यालु तर उनीहरूले जोडिरहेका हुन्छन् समेसन एक्सै काम गरेर तर फर्मुलामा अर्कोले भने कुन फर्मुला कसरी डिराइभ भयो के का लागि यो समेसनले एडिसन रिप्रेजेन्ट गर्छ यो सामान्य कुराहरू पनि दे आर ल्याक विथ दोज सर्ट अफ अन्डरस्ट्यान्डिङ द थर्ड वान इज दे क्यान सल्भ द गिभन प्रब्लम इन द टेक्स्ट बुक हैन टेक्स्ट बुकमा दिएको प्रब्लम सल्भ गर्न सक्छन् बट they cannot involve themselves in collecting real data and perform its calculation interpretation हैन एउटा विद्यार्थीलाई अथवा a learner can solve हैन problem given in the textbook हैन सबै टेक्स्ट बुकमा उस्तै खालको क्वेशनहरु हुन्छ हैन स्ट्याटिस्टिक्स हामीले हेरिरहँदा स्ट्याटिस्टिक्स क्लास 6 देखि इन्ट्रोड्युस गरिन्छ त्यहाँनिर मिनका कुराहरू गरिन्छ भनेदेखि क्लास 8 सम्म पुग्दाखेरि हामीले मिडियनसम्म पुग्छौँ, 9 10 मा हामीले अन्य कुराहरू मिन डेभिएसन स्ट्यान्डर्ड डेभिएसनका कुराहरू, क्वार्टाइल्सका कुराहरू पनि, डेसाइलका कुराहरू, पर्सेन्टाइलका कुराहरू गरिरहँदाखेरि उसले के गर्छ भन्दाखेरि he or she can solve the problem given in the textbook but cannot involve हैन कुनै एउटा उलाई सर्वे गर्नु पर्यो, कुनै डेटा कलेक्सन गर्नु पर्यो, त्यो डेटाको आधारमा चाहिँ उले इन्टरप्रिटेसन स्ट्याटिस्टिकल एनालाइसिस गर्नु पर्यो, स्ट्याटिस्टिकल इन्टरप्रिटेसन गर्नु पर्यो भने दे ल्याक इन एट दैट टाइम हैन त्यो पाटोमा अथवा त्यो बेलामा चाहिँ दे आर नट एबल टु कोप अप विथ द रियल लाइफ फेनोमेना हैन त्यो कुरालाई चाहिँ यसले जोड्न खोजेको छ भने नेक्स्ट वान इज रिप्रोड्युसिङ द सेम प्रोसेस हैन अघि माथि बनाए जस्तै हरेक चोटी चाहिँ के गरिरहेछ उसले त्यही टेबल रिपिट गरिरहेछ, त्यही कुरा रिपिट गरिरहेछ, जस्ट न्युमेरिकल भ्यालु चेन्ज गरिरहेछ र अलग अलग एन्सर मात्र निकालिरहेछ, उसले नयाँ कुरा गरिरहेको छैन, उसले सेम कुरा गरिरहेछ। दे नट एनालाइज द क्रिटिकल पर्सपेक्टिभ हैन कुनै जस्तो त्यहाँनिर हामीलाई सिधै न्युमेरिकल टेक्स्ट न्युमेरिकल भ्यालु दिएको हुन्छ र फाइन्ड द मिडियन अथवा समथिङ एल्स भनिरहँदाखेरि उसलाई त्यहाँनिर क्रिटिकल्ली सोच्नको लागि क्रिटिकल रुमको लागि चाहिँ दे आर ल्याक विथ क्रिटिकल पर्सपेक्टिभ। तर कुनै पनि डेटा कलेक्सन गरिरहँदा कुनै पनि टपिकमा कुनै पनि जस्तो कहिलेकाहीँ युज जस्तो अहिले पछाडि आउँछ युज अफ सोसियल मिडियाको कुरा गरेको छु मैले यहाँनिर। युज अफ सोसियल मिडियामा गर्दा उसले सोसियल मिडिया युज गर्न के रहेछ, कति गर्दा रहेछन्, कसरी गर्दा रहेछन्, यो धेरै गर्नु ठिक हो कि थोरै गर्नु ठिक हो, त्यो खालको क्रिटिकल्ली सोच्न सक्छ। तर सिम्पली हामीले न्युमेरिकल्ली दिएर 257 दिएर ल फाइन्ड द मिन भन्यो भने त्यसमा उसले सेम प्रोसेस मात्र रिपिट गरिरहेछ, त्यसलाई क्रिटिकल्ली हेर्न उसले सकिरहेको छैन। And the last one is how to score in examination. And as a teacher, as a learner, as a teacher, no, we majority of the teachers and majority of the students are focusing in the grades and marks of the examination. And exam ko score ma हामी focus छौं हैन। हामी पढाउँदाखेरि पनि अथवा गराउँदाखेरि पनि के गर्छौं, यसलाई यता लैजा, यसलाई यहाँ मल्टिप्लाई गर, यसलाई योबाट यो गर, त्यो मात्र भन्छौं। हामी किन गरिरहेछौं त्यो कुरा, के लागि गरिरहेछौं, त्यो किन गरेको, त्यो किन गर्नु पर्यो भन्ने कुरा हामी we do not go the reason behind those sort of things, and it lacks the advocacy of real life statistics हैन। हामी रियल लाइफमा कति धेरै स्ट्याटिस्टिकल फेनोमेनाहरु छ, कति धेरै हामी स्ट्याटिस्टिक्ससँग फ्यामिलियर छौं, स्ट्याटिस्टिक्स कति धेरै कम्पोनेन्टसँग हामी दिनदिनै इन्काउन्टर गरेर आउँछौं, बट द लर्नर्स आर lack the advocacy of real life statistics. They are not able to immerse themselves in the statistical phenomena around themselves. They are not able to cope up with the statistical phenomena exist in their environment. भन्ने कुरामा हामी ल्याक गरिरहेका छौं भन्ने कुरा यहाँ देखिन्छ। अब ती कुराहरूलाई ल्याक गरिरहँदाखेरि त्यसलाई कसरी एड्रेस गर्न सकिन्छ त, अथवा एक्सपिरियन्शियल लर्निङको कुरा गरिरहँदा अथवा स्टुडेन्टलाई एक्सपिरियन्ससँग अथवा रियल लाइफ सिनारियोसँग मर्ज गरेर हामीले स्ट्याटिस्टिक्स पढाउने भनिरहँदाखेरि कसरी पढाउने त, हामीले कस्ता खालका एक्टिभिटीहरू डिजाइन गर्न सक्छौँ अथवा कस्तो खालको प्रोजेक्ट डिजाइन गर्न सक्छौँ भन्ने कुरामा जाँदै गर्दा यहाँनिर मैले एज एन एक्जाम्पल एउटा प्रोजेक्ट लिएर आएको छु। त्यो प्रोजेक्ट छ एक्सपिरियन्शियल लर्निङ अफ स्ट्याटिस्टिक्स, यो स्टिम बेस्ड प्रोजेक्ट हो। यसमा चाहिँ यसलाई चाहिँ मैले टपिकमा युज अफ सोसियल मिडिया भनेर राखेको छु भने यसले चाहिँ यो प्रोजेक्टको थ्रुबाट स्टुडेन्टहरु गइरहँदाखेरि if they went through this, or if they apply this project, then they will get the different sort of understanding from this project हैन। यसमा के छ, the objective of the project के छ, यसको objective भन्दा this project is expected to develop knowledge, skill and competency in each of the identification area of STEAM हैन। यसलाई STEAM मा चाहिँ एक्सपिरियन्शियल लर्निङलाई कसरी जोडेर हेर्न सकिन्छ भन्दाखेरि students are expected and के कुरा एक्सपेक्टेसन गर्न सकिन्छ भन्दा to conceptualize the term of statistics, thereby stages in the statistical investigation and through अथवा by using the technology उसले गुगलको युज गर्ला, टेक्नोलोजी अन्य युज गर्ला, इन्टरनेटको युज गर्ला, त्यहाँबाट खोज्न सक्ला। त्यसलाई डिस्कस गर्छ, उसले डिस्कस गरिसके पछाडि टिचरले ग्रुप फर्म गरिदिनुहुन्छ, त्यो ग्रुपमा गएर उसले काम गर्छ, डिस्कस गर्छ, एनालाइसिस गर्छ, त्यसबाट सर्वेमा जान्छ नो। They will go to the सर्वेमा जान्छ। अगाडि हामीले कुरा गरे जस्तै सर्वेबाट के गर्छ, उसले रियल लाइफ डेटाहरु कलेक्सन गर्छ हैन। रियल लाइफ डेटाहरु कलेक्सन गरेपछि त्यो डेटालाई चाहिँ उसले के गर्छ, रिफाइन गर्छ, उसलाई ट्याबुलेसन गर्छ, डिफरेन्ट टाइप अफ उसलाई फ्रिक्वेन्सी टेबलमा राख्छ, क्युमुलेटिभ फ्रिक्वेन्सी टेबलमा राख्छ र उसलाई फर्दर चाहिने कुराहरु निकाल्दै जान्छ। जस्तो हियर what is the role of teacher? टिचरले के गर्नुहुन्छ भन्दाखेरि अघि भने जस्तै टिचर फ्यासिलिटेट्स हैन, केको लागि, कन्डक्ट द सर्वे, रिसर्च वर्कको लागि हैन, कन्स्ट्रक्ट द ग्राफिकल रिप्रेजेन्टेसन। उलाई फ्रीली छोडिन्छ, उसले पहिला आफै एक्सप्लोर गर्छ, तर उसले नसकेको खण्डमा थोरै हेल्प टिचरले गर्न सकिन्छ। अनि मेटेरियल रिक्वायर्ड हैन, यसका यो प्रोजेक्टका लागि कस्ता मेटेरियलहरू चाहिन्छन् भन्दाखेरि पेन्सिल चाहिन्छ, अभियसली पेन पेन्सिल चाहिएला, A4 साइज पेपरहरू चाहिएला, चार्ट पेपर चाहिएला, कलर मार्करहरू चाहिएला, रुलर चाहिएला हैन, अनि कम्प्युटर विथ इन्टरनेट फेसिलिटी चाहिएला, किनभने हामीले इन्टरनेटबाट एक्सप्लोर गर्ने कुराहरू गरिरहेका छौँ। त्यो गरिरहँदाखेरि उसले फिल्डमा जाँदै गर्दाखेरि कस्तो क्वेसन लिएर जान्छ अथवा के कुरालाई दिमागमा लिएर जान्छ भन्दाखेरि on average per week ask to all your friends present today हैन, आफ्नै क्लासबाट सुरु गर्दैछ। We may not limit this in our class only, we may take of the other classes as well, तर अहिले हामी एउटा क्लासको कुरा गर्दैछौँ। एउटा क्लासको कुरा गरिरहँदाखेरि कोही स्टुडेन्टले चाहिँ एभरेजमा हप्तामा कति सोसियल मिडियाहरू चलाउँछ हैन, हाउ लङ डु यु युज सोसियल मिडिया हैन, लाइक फेसबुक, इन्स्टाग्राम, भाइबर, नो दिस सर्ट अफ थिङ्स, एक हप्तामा एभरेजमा उसले कति घन्टा चलाउँछ भन्ने कुरा चाहिँ को डेटा कलेक्सन उसले गर्छ र यस्ता खालको टेबलमा उसले र डेटालाई कलेक्सन गर्छ। एउटा 2 भन्ला, अर्कोले 5 भन्ला, अर्कोले 9 भन्ला, अर्कोले 3 भन्ला, अर्कोले फेरि 3 भन्ला हैन। बट हाम्रो उता डिस्क्रिट टेबल बनाउँदाखेरि त्यसले कसरी फ्रिक्वेन्सीमा इम्प्याक्ट गर्छ, फ्रिक्वेन्सी कसरी आयो भन्ने कुरा त्यसले उसले बुझ्ने भयो हैन। क्लास इन्टरभल बनाउन सक्ने भयो धेरै डेटाहरू हुँदाखेरि। लाइकवाइज उसले यहाँनिर मैले क्लास इन्टरभलको एउटा इक्जाम्पल लिएको छु, यसै नै डिस्क्रिट टेबल पनि बनाउन सकिन्छ हैन। यो फ्रिक्वेन्सी टेबल भयो, यसमा उसले ट्याली मार्क्सको कुरा कसरी काउन्टिङ गर्न सकिन्छ, ट्याली मार्क्सको कन्सेप्ट बुझ्ने भयो, उसले त्यहाँबाट फ्रिक्वेन्सी निकाल्ने भयो। त्यस पछाडि त्यही फ्रिक्वेन्सीलाई लगाएर उसले क्युमुलेटिभ फ्रिक्वेन्सी निकाल्न सक्ने भयो हैन। त्यहाँबाट उसले फर्दर अन्य कुराहरू के निकाल्नुपर्ने छ, के चाहिन्छ ती कुराहरू निकाल्ने भयो। र क्वेसन 2 भनेर फर्दर यसमा त्यो लिएको डेटामा, किनभने हामीले त यो एक्सपेरिमेन्ट अथवा यो प्रोजेक्ट गराइरहँदाखेरि हाम्रो त्यो कोर्सले फुलफिल गर्नुपर्ने अब्जेक्टिभ पनि फुलफिल गराउनु पर्ने छ। त्यो फुलफिल गराउने कुरा चाहिँ यो क्वेसन 2 मा छ। जस्तो के छ त त्यसमा भन्दाखेरि सो द इन्फर्मेसन अफ द फ्रिक्वेन्सी टेबल इन हिस्टोग्राम हैन, उसले ल्याएको, उसले कलेक्ट गरेको डेटा, उसले रियल लाइफबाट उसको क्लासबाट कलेक्ट गरेको डेटालाई उसले केमा रिप्रेजेन्ट गर्छ, हिस्टोग्राममा रिप्रेजेन्ट गर्छ हैन, पाइ चार्टमा रिप्रेजेन्ट गर्न सक्ला अथवा अन्य त्यस्ता ग्राफिकल फर्महरुमा रिप्रेजेन्ट गर्न सक्ला। अनि लाइकवाइज इन सेकेन्ड फाइन्ड द एभरेज टाइम हैन, ले मिन निकाल्न सक्छ, मिडियन निकाल्न सक्छ, मोडल क्लास निकाल्न सक्छ, क्वार्टाइल्स फ्रम द कलेक्टेड डेटा इन्फर्मेसन। अनि यो कुराले चाहिँ जस्तो अगाडि मैले क्लास 10 को लागि यो प्रोजेक्ट डिजाइन क्लास 10 लेखिरहँदाखेरि, क्लास 10 को लागि प्रोजेक्ट डिजाइन गरिरहँदाखेरि यो 2 नम्बरको क्वेशनले अथवा यी कुराहरू निकाल्दै गर्दाखेरि चाहिँ उसले त्यो टपिकबाट अथवा त्यो एउटा पर्टिकुलर स्ट्याटिस्टिक्स 9-10 को स्ट्याटिस्टिक्सको टपिकबाट उसले त्यहाँबाट सिक्नुपर्ने कुराहरू हैन, मिनिमम रिक्वायरमेन्टको कुराहरू यो 2 नम्बरबाट पनि सिक्न सक्ने भयो। त्यसमा एभरेजको कुरा गरिएको छ, मिडियनको कुरा गरिएको छ, मोडल क्लासको र क्वार्टाइल्सको कुरा गरिएको छ। यी कुराहरूले बेसिक इन्फर्मेसन अथवा बेसिक क्याल्कुलेसनको कुराहरू यसैमा सिक्ने भयो। अ पार्ट अफ दैट उसले के गर्न सक्ने भयो त भन्दा राइट अ पोएम अबाउट द युज अफ सोशल मिडिया इन द क्लासरुम हैन, उसले पोएम अथवा यस्ता अन्य ल्याङ्ग्वेज आर्टका कुराहरू हैन, अर्कोमा एसेको कुरा छ, एसे अन द युज अफ सोशल मिडिया हैन, यो इंग्लिशमा आउने कुरा भयो। अर्को छ डेभलप 1 पेज डिबेट अगेन्स्ट एन्ड फर अफ सोशल मिडिया, उसले डिबेट बनाउन सक्ने भयो, उसले एसे लेख्न सक्ने भयो, उसले पोएम लेख्न सक्ने भयो। यस्ता कुराहरूमा पनि हामीले यो म्याथमेटिक्सलाई ल्याङ्ग्वेज आर्टसँग कनेक्ट गर्न सक्यो अथवा म्याथमेटिक्सबाट ल्याङ्ग्वेजका कुराहरू पनि निकाल्न सक्यो। त्यो कुराहरू पनि यसले एड्रेस गर्न सक्छ। अर्को छ कन्क्लुजन, राइट अ ब्रिफ कन्क्लुजन हाइलाइटिङ अपर्च्युनिटिज एन्ड च्यालेन्जेस हैन। यही कुरा गरिरहँदाखेरि उसले त्यसमा अपर्च्युनिटिजहरू खोज्न सक्ने भयो। सोसियल मिडियाका अपर्च्युनिटिजहरू के छन्, स्टुडेन्ट लाइफमा यसका च्यालेन्जेसहरू के छन्, यसका डिसएडभान्टेजहरू के छन्, यसका एडभान्टेजहरू के छन्, यी यावत कुराहरू चाहिँ उसले एक्सप्लोर गर्न सक्ने भयो। एन्ड ही अर सी क्यान मेक अ रिकमेन्डेसन हैन फर द अदर हैन, अरूको लागि रिकमेन्डेसन बनाउन सक्ने भयो, आफ्नैमाका लागि रिकमेन्डेसन बनाउन सक्ने भयो। उसले रिकमेन्डेसन बनाएर फाइनल्ली यो सबै कुराहरूको चाहिँ एउटा रिपोर्ट सबमिट गर्न सक्ने भयो। यो चाहिँ उसले रियल लाइफ डेटासँग खेल्दै खेल्दै यति काम गर्न सक्ने भयो। यो गरिरहँदाखेरि अब एज अ टिचर हामीले कुनै काम गरिसकेपछि के गर्छौँ त भन्दा त्यसबाट एसेस गर्छौँ, त्यसलाई इभ्यालुएट गर्छौँ। कसरी गर्न सकिन्छ त भन्दाखेरि स्टुडेन्ट्स एसेसमेन्टको कुरा आउँदै गर्दाखेरि चाहिँ टिचर क्यान मेक अ क्राइटेरिया, डिफ्रेन्ट क्राइटेरिया बनाउन सकिन्छ के को आधारमा गर्ने भन्ने कुरा। र त्यसलाई चाहिँ हामीले एक्सिलेन्ट, भेरी गुड, गुड, डेभलपिङ हैन, उसले बन्दैछ, गरिरहेको छ, भर्खर प्रोसेसिङमै छ भने उसलाई डेभलपिङको क्याटेगोरीमा राख्न सकिएला हैन। ठिकै राम्रै बनिसकेको छ, उसलाई गुडमा राख्न सकिएला, B+ दिन मिल्ला अथवा उसलाई न्युमेरिकल भ्यालु त्यही अनुसारले असाइन गर्न सकिएला हैन। राम्रै गरेछ अथवा राम्रो गरेछ, भेरी गुडमा जान एकदम उत्कृष्ट छ, धेरै नै राम्रो, सोचे भन्दा राम्रो छ, त्यसलाई एक्सिलेन्ट दिन सकिएला, A+ दिन सकिएला हैन। यसरी चाहिँ हामीले एज अ टिचर पनि हैन फर्मेटिभ एसेसमेन्टको लागि चाहिँ हामीले यसरी इभ्यालुएट पनि गर्न सक्ने भयो। अब यो एक्सपिरियन्शियल लर्निङ गराइरहँदाखेरि एज अ टिचर एक्सपिरियन्सियल लर्निङलाई चाहिँ हामीले इम्प्लिमेन्ट गरिरहँदाखेरि चाहिँ वाट कुड बी द एडभान्टेजेस अफ दिस सर्ट अफ लर्निङ भनेर हेरिरहँदाखेरि चाहिँ इट इन्गेज होइन, यसले चाहिँ मिनिङफुल इन्गेजमेन्ट अफ स्टुडेन्ट एन्ड टिचर इन एक्टिभिटिज, टिचर र स्टुडेन्टलाई चाहिँ एक्टिभिटीमा इन्भल्भ गरेर त्यो एक्टिभिटीबाट बढी नै लर्न गराउने, त्यसलाई रियल लाइफ सिनारियोबाट लर्न गराउने कुरा, कन्टेक्चुअल लर्निङको कुराहरूलाई चाहिँ यसले प्रमोट गर्छ भने कन्टिन्युस लर्निङ थ्रु द एक्सपेरिमेन्ट अन न्यू आइडियाज एन्ड थिङ, होइन, उसलाई चाहिँ एउटा एकचोटि एउटा रियल लाइफमा इमर्ज गरिसके पछाडि चाहिँ he or she may continue his or learning through the experiment on new ideas and things. त्यस्तै गरी they can provide student the cognitive and metacognitive tools and explore creative models, होइन, नयाँ क्रिएटिभ मोडल्सहरू एक्सप्लोर गर्नको लागि, होइन, उसलाई चाहिँ कग्नेटिभ र मेटाकग्नेटिभ लेभलसम्मको थिङ्किङको लागि पनि यसले त्यो किसिमको स्पेस प्रोभाइड गर्ने काम गर्छ एक्सपिरियन्सियल लर्निङले. And it promotes for the more understanding, innovation and cohesive education in the classroom, हैन, यो कुरालाई पनि यसले प्रमोट गरिरहेको हुन्छ भने इट प्रमोट्स स्टुडेन्ट ह्याबिट अफ थिङ्किङ आउटसाइड द बक्स. अघि हामीले अगाडि पनि कुरा गर्यौँ, इट प्रमोट्स द क्रिटिकल थिङ्किङ, होइन, आउटसाइड द बक्स कसरी सोच्ने, होइन, सिम्पली दिएको कुरा दिएको फेनोमेनन भन्दा बाहिर पनि कसरी सोच्ने, आफ्नो तरिकाले कसरी सोच्ने भन्ने कुरामा पनि स्टुडेन्टलाई प्रमोट गर्न सक्छ. त्यसले प्रमोट अल कग्नेटिभ, इफेक्टिभ एन्ड साइकोमोटर लर्निङ प्रोसेस, होइन, कग्नेटिभ स्वाभाविक रूपमा कग्नेटिभ हुने भइहाल्यो, ऊ कन्टेक्स्टसँग जोडिँदैछ, उसले रियल लाइफ सिनारियोलाई पर्सिभ गर्दैछ, त्यहाँबाट एफेक्टिभ डोमेनको कुरा आउने भयो भनेदेखि साइकोमोटर ऊ आफै इन्भल्भ भइरहेको छ, होइन, उसले आफ्नो के मात्र हेड, हार्ट र ह्यान्ड तिनटै कुरा युज गरिरहेको छ. त्यसले गर्दा यसले कग्नेटिभ, एफेक्टिभ र साइकोमोटर तिनटै पार्ट अथवा तिनटै स्किललाई पनि जोडेको छ भन्न सकिन्छ. दिस सर्ट अफ things can be these things can be addressed by the experiential learning in a learner, in a particular learner, हैन. फाइनली हामी जाँदै गर्दाखेरि तिनै अगाडिकै कुराहरूलाई अलिकति समराइज गर्दाखेरि मैले यसलाई चारवटा पार्टमा ठ्याक्क डिभाइड गरेँ, हैन. एक्सपिरियन्सियल लर्निङले के कुरालाई प्रमोट गर्छ त भन्ने कुरामा चाहिँ त्यो अगाडिकै कुरालाई ठ्याक्क मैले अलिकति स्पेसिफिक बनाएँ, लाइक क्रिएटिभिटी एन्ड इनोभेसन, हैन. यसले चाहिँ क्रिएटिभिटीलाई प्रमोट गर्छ, इनोभेसनलाई प्रमोट गर्छ, हैन. स्टुडेन्ट्स क्यान थिङ्क आउट अफ द बक्स, होइन, रियल लाइफ सिनारियोमा मर्ज भएर उसले त्यो हिसाबले सोच्न सक्छ, यसमा फिलिङ्सका कुराहरू अथवा उसले कोलाबोरेटिभ इनोभेसनका कुराहरू सोच्न सक्छ, थिङ्क क्रिएटिभली, कोलाबोरेट फर इनोभेसनको कुराहरू आउन सक्छ. क्रिटिकल थिङ्किङ एन्ड प्रब्लम सल्भिङ, होइन, यसमा रिजनिङको कुरा आउन सक्ला, जजमेन्टको कुरा आउन सक्ला, र कम्युनिकेसन एन्ड कोलाबोरेसन, होइन, ग्रुपमा काम गरिरहँदा एकअर्कामा बनाएको कुरालाई सेयर गरिरहँदाखेरि, होइन, एकवटा लिएर अर्कोले बनाएको कुरालाई मर्ज गरेर त्यसमा चाहिँ कम्पेयर एन्ड कन्ट्रास्ट गरिरहँदाखेरि चाहिँ कम्युनिकेसन एन्ड कोलाबोरेसनको स्किल पनि बिल्डअप हुन्छ भनेदेखि अर्को फाइनली टेक्नोलोजीको कुरा पनि छ. टेक्नोलोजीमा हामीले धेरै कुरामा जस्तो अगाडि एक्सप्लोरको कुरामा टेक्नोलोजीको युज गरेका थियौँ, डाटा कलेक्सनमा स्कुलको नेचर अनुसार डाटा कलेक्सनमा पनि उनीहरूले टेक्नोलोजीको युज गर्न सक्लान्, र फाइनली उनीहरूले कम्पेयर गर्नको लागि, होइन, अन्य सिनारियोसँग कम्पेयर गर्नको लागि, अन्य स्कुलसँग कम्पेयर गर्नको लागि, ग्लोबल पर्सपेक्टिभमा कम्पेयर गर्नको लागि पनि टेक्नोलोजीको युज गर्न सक्लान्, होइन. यसरी चाहिँ इन दिस वे दिस एक्सपिरियन्सियल लर्निङ क्यान मेक स्ट्याटिस्टिकल लर्निङ इन अ बेटर वे, होइन. स्ट्याटिस्टिकल लर्निङलाई चाहिँ एउटा रियल इसेन्स, एउटा लर्निङको रियल इसेन्स चाहिँ यो खालको एक्सपिरियन्सियल लर्निङले चाहिँ दिन सक्छ. स्टुडेन्टहरूलाई हामीले सिम्पली टेक्स्ट बुकमा मात्र लिमिट नगरेर, हामीले चाहिँ उनीहरूलाई चाहिँ रियल लाइफ सिनारीमा मर्ज गर्ने, एउटा सोसाइटीमा इन्भल्भ गरायौँ, अथवा एउटा त्यही स्कुललाई पनि एउटा मिनिएचर सोसाइटीको रूपमा लिएर, एउटा क्लासरुमलाई पनि सोसाइटीको रूपमा लिएर क्लासरुमबाट डेटा कलेक्सन लिन गर्न सक्यो, स्कुलबाट डेटा कलेक्सन गर्न सक्यो, सोसाइटीबाट डेटा कलेक्सन गर्न सक्यो, र ती डेटामा खेलाएर चाहिँ उनीहरूलाई त्यो डेटाको आधारमा उनीहरूबाटै क्वेसन मेकिङ गरेर उनीहरूबाटै त्यसको स्ट्याटिस्टिकल एनालाइसिस गरेर त्यसलाई इन्टरप्रिटेसन गर्ने हो भने चाहिँ इट क्यान मेक अ सिग्निफिकेन्ट डिफरेन्स. यसले चाहिँ एउटा रियल इसेन्स, एउटा स्ट्याटिस्टिक्स लर्निङको चाहिँ एउटा रियल इसेन्स लर्नरलाई दिन सक्छ भन्ने कुरा मलाई लाग्छ. दिस इज माई लास्ट स्लाइड फर प्रेजेन्टेसन. दिज आर द रेफरेन्सेस. थ्याङ्क यू भेरी मच. थ्याङ्क यू फर लिसनिङ मी.
Okay, thank you so much, Sandeep sir, for this informative and very good presentation. I think the presentation you made on the topic, the experiential learning in statistics. So statistics is one of the contents that we teach and study in school level. From the very beginning of our school, we study those numbers and statistical values and different things. But in your presentation, what I found is, so from the beginning, you just started your presentation from your practices and the experiences in the pedagogical practices that you experience in your school level as well as a teacher. And what I actually connect to my learning as well. The experiential learning is about connecting the contents and the matter and the learning to the real world and the problems that we find in the life of people in the world and the life of other being in the world. So, and similarly, you presented one of the projects. So based on statistical analysis, which is also good for exploring experiential learning in the context. So I think so. I request our participants to ask questions. If you have any questions, you can post in the chat box or ask Sandeep sir. So also I'm actually seeing Peter from Australia. So it's an honor to talk to Peter. Peter, are you there? Are you with us?
Yes, good. Hi, I'm here.
Hello, namaste. So I think you were from the beginning of Sandeep's presentation. So would you like to say a few words about his presentation and the contents he brought to us?
Yeah, look, I'm sorry, I tuned in very late. I only saw the last two slides. I was very impressed, though. I think there's a good sort of constructivist, social constructivist perspective framing the pedagogy.
Okay. Well, thank you so much, Peter. So so you are a mentor for most of us. Okay. So I think we don't have any questions for Sandeep sir. I request our participants to ask questions if you have regarding his presentation, on the experiential learning in statistics. Okay, our Dinsa is also here. Basar, namaste.
Namaste, that's all right. Please continue. I'm just here. I have a class in 10 minutes, so I just, pop in. So continue, please continue the process.
Sure. Thank you so much. So I think Deepak sir. So we'd like to ask questions. Okay, please, sir.
Yeah, I mean, it's a very wonderful presentation. I think I learned a lot from Sandeepji, and thank you for putting all those together. I don't really have like much questions. I guess only question I would like to pose at this time is I mean, yes, that's what we are practicing, and you showed us that how we are doing. The pictures you showed in like first two slides kind of depict how we teach our mathematics classroom or statistics classroom in Nepal, and actually not only Nepal, and that's pretty similar in the USA as well. I don't know, because you guys as a STEAM scholar, you might have practiced the innovative pedagogies you have mentioned in the couple of slides in the later part of your presentation. I was just wondering, like, what do you see as a challenge to implement the best practices you mentioned, in your presentation? But what is the practical challenges? I mean, what do you think is the biggest challenge to implement that kind of changes in Nepali classroom?
Yeah, shall I respond? Yeah, Deepak sir, thank you for the question. And in my experience, let me start with my experience only. In the beginning days, in the earlier days of my teaching career, I used to practice that conventional type of strategy, which I had mentioned in the earlier part of my presentation, and later I had also immersed myself in those sort of progressive pedagogies. And while implementing this experiential learning in my working station where I'm teaching, in the earlier days, in the initial form, I feel quite difficult to make students familiar with this phenomenon. They were just practicing the old strategy where I used to where we used to give the process and formula for the calculation of the certain problems which are given in the textbook, and they were also expecting that thing only, and they were not so much interested in immersing themselves in those sort of survey and all that things. So in the beginning days, that type of challenges, I was feeling quite difficult to make my learners, make my students familiar with this phenomena, with this strategy. So I think other teachers also, they may feel that type of difficulty in the beginning. And but later, when we practice one or but when I had practiced one or two this sort of projects in my classes, then after that they were much familiar with these things, and they were so much interested in learning through this approach. And finally, I was not feeling that much difficult. But sometimes we, as a teacher, sometimes we may feel difficulty in designing those sort of projects. It may take quite time. So that things might be there. A part of that, we might not have so many challenges because the datas are all around us, and we just need to collect them. And the challenge is to start these sort of things. And if we once we start practicing these in our working station, in our school, in our classes, then I hope it will be pretty easy in the upcoming days. This much from my side, sir. I hope I make you clear.
No, that's all good. Thank you. Yeah, I mean, I find it really challenging to implement any kind of like a new pedagogy you try to bring in the classroom. It's just always there is a kind of pushback from students, and yeah, that's what I was wondering, like how do you really manage the pushback you get from a student? And as you mentioned in your slide that our examination system doesn't really award to that kind of innovation, because the questions are very limited to only the memorization, and then just the procedures, so without making any connection to the concepts and so on and so forth. So if the त्यही घोकन्ते विद्या भने जस्तो क्या, तपाईँको घोकन्तेले चाहिँ अवार्ड पायो, नघोक्नेवाला चाहिँ डुब्यो भने जस्तो। त्यही भएर जस्तो परीक्षामा आउँदैन भने why do I even need to care about this भन्ने खालको
yes
आउँछ नि त। But I kind of find this like your project you showed at the end of the presentation, that project I find it a little, very much similar to Niro's this presentation in the beginning of this series. I don't know if you guys talk about it or something like that, but those are very interesting projects, and I like it. Thank you.
Thank you, sir. Thank you, Deepak.
Okay, so thank you so much, Deepak sir, for the questions, and Sandeep sir for your response. So we don't have other questions. So I request our participants to actively actually participate in this webinar, so that we can actually communicate and answer your questions, your difficulties, and the concerns you have. So with this, I would like to move forward. Rosti ma'am, are you ready? So
yes, Nita sir.
yeah. So we have Rosni Rajbangshi ma'am.
Shall I present?
Okay, ma'am. So who is an assistant professor at Department of STEM Education, Kathmandu University School of Education. So she is presenting on arts and mathematics and science education. So the presentation will be very, very useful for science educators and similarly math educators too, because she is actually mixing these two ideas, arts and mathematics, for science education. So I request Rosti ma'am to present your slides.
Sir, let me share my screen.
Sure, ma'am.
Is it coming up?
No. Yeah, it's coming.
Okay. Namaste and good evening, everyone. I see Peter here and also Deepak sir, Neeraj sir, Netar sir, and all the participants. Welcome to my presentation. My topic today is math and arts in science education. Before starting my presentation, I just want to say briefly about how I come up with this idea. In the past few years, I have been working in the STEAM department. I have been working in the CUSO, working as a postdoc as well as now assistant professor. But before that, I used to work in STEAM department and as a graduate assistant as well as a program coordinator. So I try to connect the math and arts in science education through my experience, whatever I have been doing right now, and how I see math and arts in science education, how I connected them. That's how I'm presenting today's presentation. But I would be very grateful if you all or the participants can add more to it to make it meaningful to everyone. I just don't want to be like one-way communication, just talking. But if you can also interact in between and add more of the math and arts component to whatever I'm presenting, I'd be grateful. And all the participants, I think they would appreciate as well. How I see math and science is like they are deeply connected, and I also see them as two sides of the coin. As I started putting these slides together, before that I was having a little difficulty as how I see. I know that math and science are connected, but I was having a little difficulty as trying to put them together to see the linkage between these two. But as I started putting these slides together, I saw more and more of math and science connected, arts and science connected. So I am just presenting only some of the things that I'm sorry about that. I'm just presenting some of the things that I have done. So science teaching, or how science teaching should be, is like it should be inquiry focused. And I have always focused on the use of 5E: engage, explore, explain, elaborate, and evaluate, to make the science learning and learning fun as well as engaging for the students. So in the past few years, whatever I'm teaching, the innovative pedagogy and the other classes that I have been teaching, I'm trying to use the 5E and also trying to put it more towards the inquiry. So I would just like if we are the science educators or math educators or any kind of, if we are teaching then to use the inquiry in our teaching, that helps the student, engages the students. And besides that, integrate approach also makes the learning meaningful. So as I said before, as I have been I taught science for a few years, and then at that time I was not focused on integrating approach, not with the integrated approach, science as a solely subject and teaching science. So if we try to connect the science and math or science and arts, I saw that it's there is more connection to it, and also students learn better from it. I am giving some examples. Today I have more examples and trying to relate the math and arts with the science. So we teach them about the boiling point of water, condensation, and also how the water is collected at the end in the jar. So there is a thermometer and all those things that we have seen this in a particular science classroom book. How I connected this particular experiment or particular lesson is like, the students, they learn the different shapes from here, and also the volume of the water, they learn the volume of the liquid from here. So if anyone can add anything else to this one, like this is from the science perspective, so someone can add anything from the math perspective, that would be nice. So here, this is circular in shape. And also this is triangular in shape. Of course, this is cylindrical in shape, and this as well. So does anyone want to add any kind of math to this one? What else do you see? What kind of other mathematics or we can connect with this lesson? Just some examples if you have any. Deepak sir, may I ask you? Okay. Any other participants or Neeraj sir? Okay, let me continue then. So I see these kind of connections, just the shapes from here, and also the pressure. Pressure might be another thing that we can see in this. We can connect distillation process with again the mathematics. So another example that I have is the blood group. With the blood group, in science, if the students learn about the blood group, I also see probability in mathematics. So blood group, we all know that we have 4 types of blood group. Blood group type O, A, B, and AB. These are the 4 types of blood group that we have. So how I see math in the blood group is that we have this in science. If a person has blood group A, he has A and O antigen or antibody antigen, right? If I'm mistaken, please correct me. So if a person has a blood group OB, B, he has this kind of antigen. So what happens? What is the chance or probability of a person, of a baby with the blood group O? If I ask that question, then this gives the probability. We use the probability over here. So a number of events occurring 1, and then out of 4 children, what is the probability that the baby is born with a blood group O is 1/4. So in the same way, what is the probability of the baby with the blood group AB is also 1/4. So if mother is blood group O, blood group A, and the father is blood group B, so what are the probabilities of having the blood group? So this is how we see in the science, and also the probability is also there. So the chance of having a baby with blood group O is 1/4. So that's how we also, from here, we can teach them the fraction, right? Fraction also, we can teach fraction from here, and probability. If anyone can add any kind of mathematics to this example. Hello?
I don't know what exactly
Okay.
you're looking for, Rosniji, but I mean,
Any kind of mathematics, if we can add to this example.
I mean, this fraction, I can see that fraction, but you could probably teach, your picture in the previous slide, that making like, what is that 1 out of 4 really means? Like, how is that possible? Like 1 out of 4 means in like a visual connection. Maybe we could make something like that to teach just the fraction, but I don't really see anything other. Like, I mean, any
Okay.
other mathematical concept can be taught from there.
Okay, thank you. Thank you, Deepak sir. So just asking about, like, if anyone can think of any other mathematical concept that we can teach from here. So that can be an example for those who are teaching science, they can connect it with the mathematics. So thank you, Deepak sir, for your answer. So another example that I have over here is the this kind of leaf that we have, like the patches, white patches, what kind of white patches in the leaf. So over here I see like connection of science and math in this way. So if anyone can think of anything else, you can add. In science, like the structure of the leaf, definitely what kind of leaf is structured does it have? Is it monocot or dicot? That kind we can learn from here. Then also chlorophyll is important for photosynthesis here. The person and also in the in math section, we can teach them how to find the area of the leaf over here. And also area of the leaf with the green color, if we can find out, that's through graph paper. By plotting, putting the leaf in the graph paper, we can kind of find out the area of the leaf, as well as like the percentage of the chlorophyll, like just from the area wise, how much percentage does it cover. So for this one, what we can also do is like paint the white ones with some color in it, and also put it in the graph paper, so we can count from there what is the count the number of squares from there, and also find out the area from there. And also after finding the area, we can also find out the percentage of the white patches in this leaf, and also the green, what is the percentage of the green patches in this leaf. So this is another example that I see connected with math and science. So if anyone wants to add anything, you can write it in the chat box or also raise hand. Okay, moving on to the next one. So relative motion is another one that I see connecting the science and the math together. So if two buses are traveling in opposite direction, what is the how we can what is the relative motion of one bus with regards to another? If we do that, we have to add. So also we can also teach mathematics on this one, like mathematics on this one, and also like if the two buses are moving towards the same direction, what is the relative motion of these two? So this becomes equal. So also in the movies, what we have seen also in the, yes, definitely in the movies, what we see that two cars are over there, and then the person from one bus is trying to jump to the next bus and to save or like to escape from something. So how is it possible over here is that like when the two buses are moving equally, then the relative motion becomes for each other becomes like null, right? It becomes equal. So from one bus, he can easily jump to the next bus, but the it has to be relatively the motion has to be same. So this is how I can also see like mathematics in this one. And as I started looking at this, I see many more examples that physics is related with this with mathematics. Also this is very important, like if a boat is there is the boat is moving towards one speed, and the current of the water is in one direction, he definitely has to go to have another he has to take another direction. And that also like the speed the numbers are equally important here, the speed of the boat and the speed of the current of the water, the velocity of the water. These are important so that he can determine where he started and where he has to reach. So also this is equally true for the air as well. So this is how I relate some of the mathematical concept in science, giving some examples. So another thing I want to give here is the making of a periscope. So maybe in when we were a child, you might have made this one, or you might have seen this one. So a periscope has two mirror over here, and if you want to see something like these are mainly used in the submarines to see something. If there is an obstacle, you can see something above this one, even though you you cannot reach there, or you need to hide from someone. So over here in making of the periscope also, I see like use of mathematics here. The exact measurement is very important, as you can see, like handmade periscope as an example over here. If the length of some side is not equal, then the exact precise periscope cannot be obtained, right? And also the angles needs to be, we need to know, the student need to know about the angles as well as the shape. Over here there is a square, right, rectangles and all those. And also over here you can see that the mounting of the mirror has to be exactly 45 degrees, otherwise like it also gives the concept of isosceles triangle, right? So 45-degree exactly. So if the image comes from here and it goes over there, so it teach you about the isosceles triangle, and also angles. We need to know the angles and all those. So this is just an example of connecting science and math over here. So next one, I am giving example of the EcoSan. So I just mentioned last time that I worked in Rupantaran also. Over there, while working in Rupantaran, I used like we made EcoSan toilet in one of the school of Chakabre. So EcoSan is ecological sanitation. So last time, for some reason, I asked, and they were not able to even identify ecosan, like, oh, what is ecosan, they did not know. So just wanted to tell you, like, ecological sanitation, this is very environmentally friendly toilet, right? It uses less or no water for flushing, and also uses urine and stool as source of fertilizer in the garden. So they use in our school, we are not using the stool, but we are definitely using urine as fertilizer, and we are using in the garden, and also growing vegetables out of it. So I just want to connect the science or math in this one with EcoSan. So the nutrient content of the human excreta, how much do we have, is like resource. It is resource of inorganic plant nutrient, nitrogen, phosphorus, and potassium, and some organic matters in fecal matter. So daily human excretion is let me go to the, okay, so 10 to 12 gram of nitrogen, approximately 2 gram of potassium, and 3 gram of 2 gram of phosphorus, and 3 gram of potassium. Most organic matters in feces, mostly nitrogen and phosphorus, are there in the urine. So 70 to 80% of nitrogen is there in the urine. Let me show this one. So in urine, what is the nutrient in what is the nutrient value of the urine in terms of nitrogen, potassium, and phosphorus and potassium is given here. So nitrogen in urine, it is for per 500 per liter per year. So around 4 it is there. So I am a little confused about this liter per year. How is it converted? So in urine, let's see, it is 4 there. And now the total amount of nitrogen is 4.5, and required for 250 kg of cereal, to grow 250 cereals of kg of the cereals, they require 5.6 5.6 kgs, right? So what happens is that we have enough amount of nitrogen in our urine to grow around this much of cereal. So we just have a little bit lagging over here. So that can be supplemented through extra, but like we do not have to provide most of it. Like most of it can be provided through our urine, and also from phosphorus in the same way. We have like 0.6 liter, let's say liter, and then we need like 0.7, so there's just a difference of 0.1. So potassium in the same way. So potassium, like it's almost like our urine almost covers whatever is needed to grow 250 kg of cereals. So this is by one of our professors, Manoj Pandey from NMBU. I have taken this one from him. So talking about the nutrient content of the human excreta, now I'm moving on to, okay, let me move to the next slide. So how we can teach this one, what we can teach, or what we can teach. So urine use as fertilizer increase the yield 3 times for leak. Like if we use urine as fertilizers, the yield is like 3 times more than what when we use the commercialized fertilizer. So also from here we can teach them about the concentration of the urine, and also the level of dilution. From here, we can teach ratio 1:1, 3:1, 10:1. So what does this one mean over here is like if we use one part of the water and one part of the urine. So this is how we can use in the garden, like water the dilution like 1:1 in 1:1 ratio, or 3 part of the water and 1 part of urine, or 10 part of water and 1 part of urine. So we can use different concentration of the urine, and also from here we can teach them like how to dilute, or what is the ratio, what does the ratio mean over here. So from here, from EcoSan, or the use of urine in the garden as fertilizer, we can teach them dilution also from mathematical perspective. Where is my next slide? Okay. Also now, talking about the EcoSan with connection with the science, how do I connect it with the science? Is the nutrient for, these are some of the nutrient for the plant that I've already discussed. And also nitrogen cycle, we can teach the student nitrogen cycle from here, a phosphorus cycle as well as potassium cycle. And with the connection with the math house, I see EcoSan or the urine diversion toilet with the math is that we can teach the student about the ratio, percentage, as well as the profit and loss. How much uh, uh, urine or we have used in the garden, and what is the gain from there, right? Versus what is when we use the commercialized fertilizer, how much we spend on that one, and what is the profit from there. So this is how we can teach the student about profit and loss in the EcoSan toilet. Now I from there I'm moving slowly towards art and science. As an example, I have this I think we as a children or as a student, we might some of you might have done this one. So in bottle we can fill out like different levels of water over here, and with the spoon we can make different sound. And so in science we can teach about the sound wave, right? Sound as a wave energy, and different levels of water give different sound as a so it gives different sound from here. As for the mathematics, we can teach the student about the volume of the water. I think I do have a YouTube video, a very short one. If time permits, can I show, Nita sir?
Yeah, yes, sure, ma'am.
Okay, a very short. I would not take much time. Can you see my screen?
Yes, ma'am.
Okay. So I think we have seen this one. I have a bad storm outside, so my connection might not be there. Hello. I think I
Yes, ma'am. Yes.
stopped sharing my. Sorry about that. I stopped sharing my screen. So I just want to show you. Is my screen visible?
Yes, yes, ma'am.
Okay, thank you. So I just from there I just want to show you like the from science sound wave or energy from here wave energy. From there we can make different kind of sound and also music from here. So that's how I see the connection of arts and science. And also from mathematical perspective, the volume of water definitely adds to it. Now I am giving a small example of geodes. Deepak sir might be familiar with this one. So, in what are geodes? Geodes are the plain rocks on outside, but have beautiful crystals inside. So these are some of the geodes, right? So some geodes are formed by silification of the organisms, such as corals and sponges underground, like in the oceans. And geodes consist of quartz, silica, calcite, and different kind of other minerals. So from mathematical perspective, how I see is like spheroid, obsolete spheroid, irregular shapes. So we can, from here we can see different kind of shapes over here. So this is what we can teach the student, the shapes and the there might be some triangle, pentagons, and other different things in the geode. So this is how I see the connection of the arts. So this is science, right? Definitely the because of the pressure and also the silification of the organism. What happens is that geodes are formed. But also in this particular geode, I see arts in it, like beautiful structures and different colors are there. So this is an example of one of the geodes that we have in what that we have in the university library. And so these are even taller than me, just showing you the one of the example. So that is from outside. So another example I have is like the uh, surface tension of the water, as well as more atmospheric pressure. With this one, like we all know that we have practiced this one in the children, when like putting the two glasses of water together and pulling up the paper from inside. That's because of the surface tension and also atmospheric pressure. I do have another small, very short video that I want to show. I think we should explore a few solutions. Grammarly suggestions. Okay.
This is a chandelier of test tubes hanging upside down with water inside without a lid. The water stays in place without pouring with the help of surface tension and atmospheric pressure of the air. So let's try with this test tube. You first put water inside. So today I put a little bit of ink in the water so that you can see from the distance. You put water inside, and then you flip it, and the water stays inside. And once it's balanced, it stays in place until it evaporates and becomes empty. And in the exhibition halls, I usually hang them up in the ceiling. And you can actually look up into the surface of the water, which is a very interesting view that you don't get to see every day.
So that was just an example, another example of connection of arts and science. So just wanted to share with you that one. So another thing that I did while I was working as a graduate student is like make some pop-up cards. So over here, while making these pop-up cards, what I did, like the students, they have batteries, some copper wire, and some LEDs. With just these things, they learn about the circuit and also make beautiful pop-up cards. So I just want to show you some examples about okay, So some of the pop-up cards, that these are what the students made. So I'm watching you, and he had these eyes, want to play. He had a picture of the chess. So from here, what the students they did was they learned about the circuit, parallel circuit, series circuit, as well as conductor and insulator. So what happened is that over here also I see the integration of arts and also arts and science over here. And how we can connect this with the mathematics is most probably the LEDs, increasing the number of LEDs in the parallel circuit, and see how the distribution of energy is there. And also maybe in the series circuit, if you put more LEDs, then what happens. So you can definitely see from that side, and connecting, trying to connect it with math. So if anyone wants to add anything on that one as well. So this was what I was planning to make the students do, and that was what came out. So with simple battery and the copper wire and LED, what happens is that the LED lights up, and then you can have the pop-up card as well. So connection of this arts with science, and also there are many more to explore. These are some of the things that I have practiced myself, and I just wanted to share with you all. So if anyone wants to share your use of math and science in the science classroom, then arts in the science classroom, then you can definitely do that over here. And with this, I end my presentation. Thank you very much.
Well, thank you so much, Rusty ma'am. So it was really a wonderful presentation, informative one, and I enjoyed a lot. So I request our participants to have to ask any questions if you have,
Or maybe
or we
share
can interact.
some of your ideas as well. You can do that.
Yeah.
Maybe because of the storm, I think we lost many participants.
Okay. So Deepak sir, you might have questions. Rabina ma'am is also, a science educator.
Yeah, I'd like
Teacher.
to just make a few comments if I may.
Yeah. Sure.
Well done, Roshani. Very interesting indeed. As you know, I'm really keen on bringing the arts into the what we call the STEM area: science, technology, engineering, and mathematics, for a number of reasons. And we have a book that's currently with the publisher, with some examples of how people are doing that at different levels, from primary school through secondary education and into university education. But before I say any more, I just wanted to ask you a question, Roshani, because I don't quite understand the context of what you've just shown us. Is this your research for postgraduate studies, or why are you doing this?
Thank you, Peter, for the question. So actually, I'm working in the STEAM department right now, and then before that, I used to work in STEAM, STEM. This is like before that, I used to see only science as solely one subject, and not trying to integrate even the arts or the mathematics into it. So
Yep.
after working for quite a while in the STEAM now and in the STEM department, so I see the connection of the mathematics and arts in science education. And also I think that these components make the science learning very fun and engaging for the students. So I'm sharing from my past experience. I have a very bad storm coming up.
Yeah,
Okay.
I understand that. I heard you say that earlier on. I guess I was wondering whether you're teaching this to students at the university, perhaps. That's your role as a teacher?
Now, some of the things that I shared was when I was working as a graduate assistant, but right now I'm teaching my students and they are actually the teachers from teachers who teach in the primary and secondary level.
Okay.
So from today's sharing, I just want my students or student teachers to know that how to make connection of this arts
Yeah.
and
Right.
mathematics with the science.
Okay, I got it. Thank you. So how do they respond when you first introduce them to bringing the arts into an intimate relationship with science and mathematics? Are they shocked? Are they surprised? Do they reject it, or do they immediately fall in love?
In the beginning, they kind of like hesitate. I wouldn't say reject, but they hesitated. And then this is like I'm talking from my previous experience. So they hesitated to use the arts component or math component into science. But later on, after they make the final product, or like they see the final product, and as Sandeep sir was also talking about the experiential learning. So when they
Yes.
are engaged in the experiential learning and they do it themselves and they understand the components of the like mathematics and art component in the science education, then they understand. When the student teacher they understand, then only they can apply it in their classroom. So that's how I've been doing. So I don't know if I answered your question or not.
No, well, that's good. Thank you. I mean, we could sit down and have a long conversation about this, but
Yes,
unfortunately,
definitely.
we don't have time because I'm fascinated by it. Let me just say to you what my engagement was like just then, listening to your presentation with the geodes. Wonderful example of studying, geology and crystals and bringing science and maths together. The thing that really struck me, though, was this notion of aesthetics, the actual beauty, the experience of beauty. Now, I think that's something that is so valuable to help with students' engagement in more meaningful and experiential learning. Do you talk to your students about the concept of beauty and aesthetics?
Thank you, Peter, for that question. I have read your paper about that one. But at that time, when I was engaged, at that time I did not. But as I started exploring about the connection of the arts and science and about the aesthetic values, now I'm thinking like I should have, but at that time I didn't.
Okay, all right. And then with your surface tension demonstration, for somebody who sees that for the first time, particularly children, they most likely think they're shocked. And there's a great mystery involved here. And I think, if we can get students engaged in a sense of mystery, how much more engaged would they be in the learning process? So just those two aspects of the arts I thought were really outstanding, Roshani. And, I think what we should be doing with science and maths educators in particular is to give them a little bit of scholarly understanding about the nature of the arts. We have the visual arts, we have the performing arts, we have language arts and so on. And rather than just sort of say, look at this surprising, beautiful thing, explain to them, why that's important. Now, I'll just give you one little example of one of the chapters in our forthcoming book. There was an art teacher and a science teacher working together in a primary school here in Perth. And the arts teacher was really concerned about what is happening to the coral reefs in the world at the moment because of global warming. You may know that the oceans are becoming more acidic. Yes. And off the Australian coast, we have some beautiful coral reefs, world famous. One of them is the Great Barrier Reef off the coast of Queensland, world-class natural environments that are now being severely damaged by climate change. So she then spoke to her science teacher colleague and they decided to integrate the two subjects. So while the science teacher was teaching the concepts that I've just mentioned, such as ocean acidification and the impact on living things such as corals, what the art teacher was doing was to get the children to take clay and to actually make model corals. So the whole class then had their collection of these little statues, which are corals from the coral reef. Now, she deliberately did not paint them. Can you imagine why not? Leaving them white. When you bake the clay, it goes white.
Yes. Okay.
Okay, so she did that. Yeah, go ahead, please.
I think for the purpose of not painting is to make them more engaged in making more, because like that later on, if they start painting, then they would go into the artistic and not on the content of the science. Is
Okay,
that?
okay, that's an interesting concept. I hadn't thought of that, but I'll tell you what her intention was. She showed the children photographs of live corals. Now, you know, I'm not sure whether in Nepal you have the opportunity to go in the ocean and see live corals, but they're very, very, very colourful, beautiful, you know. When the ocean warms and it becomes more acidic, the corals die and they turn white. The living organism then disappears from the skeleton. The skeleton is just white. So what she wanted the children to do was to then create an exhibition, a display of all these white corals that basically were dead. And then she invited the parents to come to the school, and the children took on the role of explaining to the parents the problems of climate change. Now, these are children in primary school, you know, very young, and yet they were able to take on that role of having moral agency in helping their parents to better understand about the importance of sustainable development, particularly in relation to these coral reefs. So I just put that up there as an example of how the arts, in this case, can be used in connection with science to really engage not just the kids, but their families as well in understanding and appreciating what happens when beauty disappears from the face of the earth. So I'll conclude there, Roshani, and say thank you very much. You're doing some wonderful work, and I'm sure it's of great felt interest to yourself and your students.
Yes, definitely. Thank you, Peter. Thank you for your suggestion and comments, and also beautiful examples that I can add to my stories now. Thank you. If anyone have any other questions,
If I may.
yes, Deepak, sir, please go ahead.
Thank you for that wonderful presentation. And I think now, you know, I'm kind of looking at the textbook we have for that integrated learning. I think we now say that the grade 1 to 3 is integrated learning, and then I kind of find your presentation sort of goes along that integrated curriculum thing as well. I mean, I'm not very familiar with STEAM and STEM education, all those things, but I do research in textbook, and I feel like, you know, that science, connecting science with mathematics and other parts, that goes with that integrated learning curriculum as well. Now, you know, it's happy to hear you speaking. And I mean, it's been a while that we haven't really talked, and I kind of remember that good old days. My wife was also with me. She was listening to me when you were asking that comment, and I was commenting, and she was like, "Okay, so I think you missed the whole point about this presentation." I was like, "Why?" And it's like, you know, you're just talking about fraction, but I do see that the whole probability being taught from there. And so now my wife is teaching me here, and she's listening to you, and she's saying hi to you as well.
Hi.
Yeah, so you have more audience than it seems here. So, but yeah, I mean, you know, overall, I kind of liked it, and I think I was about to ask the same question Peter asked it earlier. That yes, why exactly this presentation? Are you doing the teacher training? Are you doing something like you're implementing in a classroom, or is it something like you're writing about, or how are you going to use this? That's what was my question, and I think you probably answered that. I don't know if you haven't. Maybe you can. Yeah.
Okay, thank you, Deepak, sir. So now as I'm thinking and as I'm listening to you as well as Peter, and I'm also thinking like I should be writing more towards this integrating math, arts, and into science education as well. So also I would like to thank Deepak sir as well as Peter for intriguing that on me. I would definitely think of that one and try to have some research on this one and also write some papers. Thank you, Deepak sir, and thank you, Peter. Thank you.
You're very welcome,
So,
Roshani.
thank you, Peter. So if anyone has any question, otherwise I think Neta sir, up to you.
Yeah. Thank you so much. So, actually, I was enjoying the conversation. Deepak sir and Peter has have actually added something to the presentation that Rosni ma'am made today. So with this, I think we're at the end of today's seminar. I would actually like to thank all the participants, but we have very few participants right now. So thank you so much once again. We'll meet the next session next week. Okay, have a good night, a good day, wherever you are.
Thank you. Thank you, Neta
Thank
sir.
you. Thank you so
Good
much.
night, everyone. Thank you.
Yeah, cheers. Bye-bye.
Thank you.
Bye-bye.
Bye bye.
Bye.
Bye-bye.